Welcome to my channel. This channel is specialized in solving FE exam problems for civil engineers. Today I will solve about three fluid mechanics and hydraulics problems. So let me share my screen. Okay, problem number one is about a venturi meter. We want to determine the flow in a venturi meter. Let me draw the problem. So we have a venturi meter, something like this. So in a venturi meter, it is a pipe, something like a pipe, and there is a reduction in the area, which is called the throat here. This is the full suction area, section 1, for example, and section 2 is the throat, where there is a reduction in the area. Now, this reduction causes a pressure drop because the velocity, as the cross-sectional area reduces, the velocity increases, and consequently, the pressure drops. So by knowing the pressure or by measuring the pressure drop, we can determine the flow in the venturi meter. Now, all other devices, similar devices like the orifice plate and also the nozzle, they follow the same, very, very similar in terms of principle. Now, in this problem, we know that we know the diameter at section 1. D1 equals 0.2 meter, and we know the diameter at the throat. D2 equals 0.1 meter, and we know the pressure drop, which is 2000 Pascal. Delta P equals 2000 Pascal. So by knowing this information, the pressure drop and the sections 1 and 2, we can determine the flow. So to determine the flow, we simply follow or apply Bernoulli equation. So the required is determine the flow in the pipe. So to solve this problem, we apply Bernoulli equation between sections 1 and 2. So we write Bernoulli equation between sections 1 and 2. So Z1 plus E1 over gamma plus E1 square over 2G equals Z2 plus P2 over gamma plus B2 square over 2G. So this is Bernoulli equation between section 1 and 2. This is Z2. So in this equation, there is an elevation term, which is the Z, Z1 and Z2. So whenever we have an elevation term, we have to select a reference. So for Z1 and Z2, we have to select a reference. And to simplify our calculations, we usually select the reference at the center of the pipe. So this is the data where Z equals 0. So again, we go back to the equation. So as the datum is at the center line, so we now know that Z1 equals Z2 equals to 0. Now in this equation, we now eliminated in Bernoulli equation, we eliminated Z1 and Z2. So I want to put now the pressure terms in one side and the velocity terms in the other side. So I will have P1 over gamma minus P over gamma to the P2 over gamma to the left side. I will take 1 over gamma out. So we have P1 minus P2 equals V2 square over 2G minus V1 square over 2G. I will take 1 over 2G out. So I have V2 square minus V1 square. Now in this equation, P1 minus P2, which is the pressure difference, is known. Gamma is known, G is known. V1 and V2, we can now express V1 and V2 in terms of the unknown, which is the flow. Now what connects the flow and the velocity is the area. We know that Q equals VA. Okay, this is flow equals the cross-sectional area multiplied by the velocity. So now we substitute in the equation. Let's give it a number. We substitute in equation, let's say equation 1. We substitute the values of, we have 1 over gamma. Fine. P1 minus P2 is 2000. This is given in Pascal, equals 1 over 2G. Now, V1 square is, now V is Q over A. So Q, V1 square, Q square over A1 square, which is pi square V1 square over 4 square, which is 16, minus V2, this was V2, okay? Sorry, this was V2. So here we have V2 square over 16. So minus, we have Q by 16 over pi square D1 square. So this is the equation. Now in this equation, we know gamma. So gamma for water is 9810. 9810 kilonewton per meter cube. And G, we know G is 9.81. And we know T1 is given and D2 is given. D1 is 0.2 meter and D2 is 0.1 meter and D1 is 0.2 meter. So from in this equation, there is only one unknown, which is Q. So we solve for Q and we get Q equals Q equals 0.016 meter cube per second. So this is the answer to this problem. We solve for Q by applying Bernoulli equation between section 1, which is the full flow section, and section 2, which is the throat section. Now in the venturometer, as well as in other flow measuring devices and for pipes, we need to know the full flow diameter and the small diameter, the orifice or the throat or the nozzle, and the pressure drop. We can then determine the flow. If you have any questions about this problem, please leave me a comment and I will get back to you. So I go now to the second problem, which is about hydrostatic forces. So we have a gate, a trapezoidal gate submerged under water. So if this is the water surface, let me show you what's given. If this is the water surface, now the gate is underwater, something like this. This is the gate. Now the height of water above the gate, the water height above the gate is 2 meters. And the gate itself is 3 meters. The gate is 3 meters. The height of the gate is 3 meters. And the gate is trapezoidal in the cross section. This is the cross section of the gate. It's 4 meters at the top and 2 meters at the bottom width. So this is the cross section of the gate. And here, the slide, okay. So the distances are as follows. This is 4 meters top width, and the bottom width is 2 meters. Now we are required, this is the gate. So again, to make the question clear, so we have a gate, trapezoidal gate. It is submerged underwater. The water height above the gate, the top of the gate is 2 meters. The gate is 3 meters deep, and its cross section is trapezoidal, 4 meters the top width and 2 meters the bottom width. And this is the height. This is 3 meters. And we are required to determine the hydrostatic force acting on the gate. Now, in this type of problem, we use the formula. Now, the force equals pressure by area. Okay, this is very basic definition. Force equals pressure by area. Force equals P average multiplied by the area. Now, area is the area of the gate. It is a trapezoidal gate, so we can find the area. So now we want to determine the pressure. So the pressure, it is the average pressure, P average is the pressure at the centroid of the gate. So we want to find, so P at the centroid equals gamma Y bar, where Y bar is the centroid of the gate. So we want to determine Y bar. Okay, we want to determine the centroid of the gate. It is a trapezoidal gate. So let me draw the gate again. So the gate is like this. This is 4 meters. Yes, this is 4 meters. And this is 2 meters. And I want to determine the something like this. Okay. This is 2 meters. And this is a 3 meters. So how do we determine the centroid for this shape, for the trapezoidal shape? Now we know that the centroid is, now we can divide this trapezoidal into two triangles for which we know the centroid and a rectangle, for which it's easy to determine the centroid. Now for the rectangle, now we know that y bar, the formula how we determine the centroid for the trapezoidal or for a composite section is sigma, or let's say y bar equals sigma yi ai divided by sigma ai. So we simply take the centroid of each shape, multiply it by its area, and then we get the summation and we divide it by the total area. The total area. Now let's first get the areas. So we have area 1, area 2, area 3. So area 1 is a triangle. The width is 1. This is all 4. So this is 2. So this is 1, and this is 1. So the area of triangle is the base, half the base, which is 1, by the height, which is 3. So A1 equals 3 over 2 is 1.5 meters square. And A2 equals A1 the same. A3 equals A1 the same. Okay. Just a triangle. A3 equals also 1.5 meters square. Now A2 equals, it is a rectangle. We know that it is 2 by 3. That's simple. 2 by 3 equals 6 meters square. Now summation of areas is 9, which is 6 plus 1.5 plus 0.5, and we know each area. Now we want to find sigma y bar ai, yi bar ai. So sigma y I bar ai equals, and we take the y from the water surface. The reference is the water surface. So here the y starts from the water surface. So this is the y. Y equals 0 at the water surface. So we apply this formula again, sigma yi. So y1 is y1 bar. What's y1 bar from the water surface? Now the water depth above the rectangle is 2 meters. Okay, so we have now for the rectangle, the centroid or the y bar is 1/3 of the height. So the y bar for the rectangle is 1 meter. From the top of the gate plus 2 meter the water height. So y bar for the rectangle is, for the two rectangles, is 3, which is 1 plus 2. And y bar for the rectangle, so this is, the rectangle is 3, so this is 1.5 from the top of the gate, 1.5. So plus 2, so it is 3.5 from the water surface, which is our reference. So we go back and apply here. So Y1 is 1.5 multiplied by, we said 1 plus 2 multiplied by 3 multiplied by 2 for the two triangles, plus for the rectangle, the area is 6. Okay, this is 1.5. Let me just check that I did the multiplication correct. So the area is 1.5. Okay, right. By 2. And for the rectangle, the area is 6. And the Y bar is 1.5 plus 2, which is a 3.5. So this is the summation. Let me say Y bar, if we divide it by, because I have the answer for Y bar equals sigma YI AI divided by sigma AI, which is 9. Okay, summation of the areas is 9. So if we do the calculation, Y bar equals 3.33. So Y bar for the trapezoidal shape is a 3.33. Now we can calculate the pressure at the centroid. So P at the centroid equals gamma H, which is 9.81 kilonewton per meter cubed by 3.33. So this is the pressure. We multiply it by the area of the gate, which is 9. And we get the, this is the pressure, sorry. So this is the pressure in kilonewton per meter square. So F equals the pressure 9.81 by 3.33 by the area, which is 9. So the force is 294 kilonewton. So this is the answer. The force is 294 kilo in Newton. Again, in this type of a question, when we are asked to determine the force, we first find the centroid, the geometric centroid of the gate, whatever, if it is rectangular or circular or trapezoidal. Then we determine the pressure at the centroid, which is gamma by the centroid, gamma H, which is the distance from the top of the water surface, and then we multiply by the area. Now, this type of a question, it takes some time in the exam, so one should actually practice to do it quickly. The simplest case is if the gate is rectangular, so it won't take time to determine the centroid of the gate. So if you have any questions about this problem, please leave me a comment and I will get back to you. One more question about the determination of a runoff, direct runoff. So we have a catchment area, a catchment where rainfall equals on a catchment, rainfall equals 75 millimeter. And we have the curve number equals 85. So we want to determine direct runoff. Determine runoff by using the curve number method. Determine runoff by using the curve number method. So for the curve number method, we first calculate the retention, maximum retention, the S so S equals 25,400 divided by the curve number minus 254. So we know the curve number is 85. So we substitute 85 for the curve number and we get S equals 44.82 millimeter. And after that, we calculate the initial abstraction, IA, initial abstraction, IA. So IA, there's a formula for IA. So IA equals .2 by S, 0.2S. Okay, that's very well-known formula. So it's 0.2 by 4482, which is initial abstraction, is 8.96. millimeter. So then we determine now the Q. There's a formula for Q. So Q equals E minus initial abstraction, E minus initial abstraction square divided by P, which is a precipitation, minus IA minus S. So in this equation, we know the P is known. P equals the precipitation is 75 millimeter. P equals 75 millimeter. And we calculated initial abstraction, this is 8.96, and we calculated the storage, which is 44.82. We substituted the numbers, and we get U direct runoff equals 39.34 millimeter. Or millimeter. So this is how we solve this type of problem. So this is, again, you have only to substitute the numbers. You first have to calculate the retention, the S, the maximum retention, the S, then initial abstraction is 0.2 from the retention, and then you calculate the flow using this information. This is the curve number method. If you have any question about these three problems, please leave me a comment. If you have any other problem you need help with, please also send me a comment and I will get back to you. Thank you for watching my channel, and I look forward to seeing you in the next video.